So question 13 says, equal lengths of two copper wires W and Z are connected in parallel in a circuit as shown. Wire Z has twice the diameter of wire W. Wire Z has twice the diameter of wire W. Okay, so that means wire W is a thinner wire. Explain why the drift velocity of charge carriers is the same value in wires W and Z. So the first point you need to write is Z has a greater cross-sectional area than W. Z is more thick, so it has a greater cross-sectional area. And if the cross-sectional area is greater, so it has a smaller resistance. Why? Because resistance equals rho L by A, right? So resistance equals rho L by A. So if you have a larger area, you'll have a smaller resistance. So Z has a greater current through it because voltage is the same, V equals IR. If voltage is the same, smaller the resistance, greater will be the current. So according to I equals to NAVE, with both A and I 4 times greater in Z, drift velocity is the same. Look at this. I is greater and the area is also greater. So that's what makes the drift velocity constant. For B, wires W and Z are now connected in series. Complete the table by placing a cross in the correct box for each quantity. So we all know that current remains constant in a series circuit. So if they are connected in series, it means the same current flows through both W and Z. So current is the same for both the wires. And since this is thinner, resistance equals rho L by A. Since it has a smaller area, it has a greater resistance. So W has a greater resistance. And in a series circuit, the greater the resistance, the greater is the potential difference. So potential difference across W will be greater. And about the drift velocity, since current is the same, since I equals NAVE, current remains the same. So this has a smaller area, so it will have a greater drift velocity. So drift velocity will be greater.